larger, the overlay grid, but from time to time we have to look into the smaller structures, and that is what microgrids also is about. I was told I will not be allowed to speak more than 15 to 20 minutes. No, don't worry. I'm more or less done in introducing the topic, and I'm most happy to pass over the word to Krishna, who will now make the initial presentation. And I do see that a number of people already started writing into the questions and answer sessions, and I will be happy to forward a number of those questions to the presenter after the presentation. Krishna, please.
Sure, Frank. Appreciate your opening remarks, and I'm in full agreement with you that microgrids, the way they are implemented and the way they are visualized, can lead to a revolution in the way energy is supplied and utilized. So allow me to share my screen, and we'll go on to the presentation itself. I hope that is visible, which is another standard remark that I have to make in every session that I have. It's not going away. How do I make this top bar go?
Krishna, you can press the play button.
Yeah, but the play button is hidden behind the bar, and the bar is not going. I think I need to open up the Q&A.
I can try to guide you. If you move the cursor a little bit further up, no, down, and stop. Right. It was a little bit too much right. A little bit more left. Little bit more, little.
Maybe you
can
can
this one?
drag this bar and then you can keep it down.
Oh, yes, I got it.
Yeah,
Great.
yeah.
Great. So here we are, and let me start my presentation on the Microgrid Technologies proposed Center of Excellence. I welcome you to this talk. So the outline of this talk is then going to be in this manner. We'll talk about introduction first and an overview of microgrids as they are around the world. What are the goals and questions that we have for this proposed Center of Excellence? And what is the work plan that we have? And how do we look ahead from that? This is the outline of the talk, and let me go to the introduction. So what is this all about? And this is about us, a few of us from IITM who work in various disciplines, but all of them interlinked by energy. We have been working in the domain of energy for quite some time now, many of us, and have been on the way of developing some technology solutions, etc. Some have been attempted for deployment as well, and so on. And we would like to then come together and explore our mutual expertise, how they can benefit society by way of combining these sources into the form of microgrids. But as we see, everybody is aware of electrical grids, but we would like to broaden this idea itself into an energy microgrid, where, for example, if you know, electricity is one of the ways in which energy is conveyed from the source to the load, but there are other ways as well. And if you look at, for example, industrial applications, heat is one of the main sources of energy that is used directly as heat in industrial applications. So we would like to broaden this definition of microgrids into an energy microgrid where, for example, if you have a heat source, that itself could form its own grid, not necessarily connecting to the electrical domain. And then we would like to explore deployment or use of these forms of grids in different geographical locations, rural, urban, hilly areas, and then going ahead into looking at how we can then form local energy communities, which would then operate these grids with locally available resources of energy. So this is what we would like to inquire into and look at and see whether we can come up with solutions that would be appropriate for this kind of a application. In this, we would be also interacting with the IGCS and the Center for Technology at IIT Madras. We hope that this interaction will give us a lot of benefits by way of understanding and deploying the sort of technology. So let's look at how microgrids, the use of microgrids is not new. Microgrid deployments have been happening all over the world. And here we have a sample of microgrids. And this bar is coming in my way. Yeah, this is good. So here I have listed several microgrid implementations on the right-hand side, each one represented by a certain shade of yellow, blue, etc. And on the graph here, on the x-axis, I have listed the variety of sources that are used in this grid. And on the y-axis, it represents the capacity of the source used in a particular location. For example, if you look at the area of diesel generator sets, and you look at this bar, it then means that this shade is representative of the island in India, Lakshadweep. And this means that the capacity of diesel generator sets that are deployed in this location is that capacity and is deployed in this location. At the same time, DG sets are also deployed in a location corresponding to this shade, which is located in Denmark. And the capacity is indicated by the length of this bar, and so on. Right, one can observe from this, this is an interesting graph. One can observe from this that there are a variety of sources that have been used in the deployment of microgrids. You have diesel generator sets, photovoltaic cells, and then energy storage, gas, and so on. But interestingly, if you see, as you go to the right-hand side here, while you have steam turbine, biogas, tidal wind, etc., the number of deployments of these grids using this particular source are quite few. There are, for gas, for example, there are just 1, 2, 3 varieties of 3 different locations. CHP is 2, wind is used in 1 particular location, and so on. As you come to the left, you see that the number of deployments of these particular sources are quite large, especially for photovoltaic and DG sets. And you can see that the diesel generator sets have a wide variety of shades here, which is representative of almost all the colors, which then means that diesel generator sets are practically used in every single deployment of these microgrids. Similarly, here also you see that there are many shades, which means that photovoltaic systems are used in almost all deployments. But the key thing to look at is look at the size of the deployments here, whereas as compared to the size of the deployments here. So deployments of grids in usable locations seem to clearly say that they have the approach to go is one large energy source which can possibly meet all the requirements by itself, and then add on certain other sources to it. The goal mainly being to reduce the amount of consumption of diesel so as to reduce emissions and so on. So this is generally the philosophy. And the next slide, therefore, gives you a summary of observations from these installations, with the largest source contributor being diesel gensets, somewhere in some locations where gas is available in abundance, it is natural gas. Steam turbines are used, again, very specific locations. The widely used sources are diesel generator sets, photovoltaic, and some amount of storage by batteries. And the general approach has been to have a stable dispatchable power source and some addition of renewables. Renewable amount of renewables, as you can clearly see, is not very high, it's quite small. Another major observation that one can see from reading about these deployments, information is available on the internet, for those who are interested, is that most of these microgrids are managed by centralized systems. Another important aspect that will come into operation is the aspect of asset ownership, which seems to be single in the majority of cases. And there are multiple types of sources that are used. So this observation forms the basis from which to look at what is it that would be desirable and interesting questions that are to be asked. So with this then, for us, what would be the questions that are to be addressed? How do you extend these deployments to make use of resources that are not available in large amounts? Small capacities, if they are there, for example, low speed wind, right? Would it still be feasible to make use of that and so on? Then the other question is, what are the technologies then that are appropriate for microgrids in villages in such a way that energy communities can be formed, which will make use of locally available resources and not depend on importing resource from outside that particular zone. Urban microgrids are very important. Usually when we discuss about this area, we only have, remote villages are visualized, but then urban microgrids are also important, especially in situations like India, where even in urban locations, you can have the grid being inactive for some time for various, insects for different reasons. And in such a situation in urban areas, waste is something that is usually available. And how do we engineer systems where waste can then have a role in generating energy? If we go to hilly regions, small hydel and wind are available, but how do we make them economical? Which would be an interesting question. Industrial areas, as I mentioned earlier, can we make use of steam for supplying the energy? Can we have a linking of industrial areas via a grid comprising of steam? And another important aspect here is storage. We all know very well that without storage, microgrids would not work, because you need to have energy available when other resources are not there, which means storage is important. But then if you look at energy storage as it's discussed today, especially when looking at electric vehicles, people talk mainly about storage via lithium ion. It is good for that purpose because lithium ion affords very high energy densities. But then here we are looking at energy storage that does not need to move. And therefore, the question is, can we do with slightly lower density energy storage, but then can give better performance over a number of charge-discharge repetitions? So flow batteries is another thing which we would like to investigate. And then comes the all-important aspect of regulations, how they can help in the deployment and how they can help in the operation of these varieties of grids. These are important questions for us, which we would like to address in the proposed Center of Excellence. So the overall action envelope that we are looking at for the Center of Excellence is that we would like to develop technologies which would suit a diverse variety of sites. And we would like to develop technologies which make use of slightly marginal energy sources as well. Another thing that we would like to look at, especially from the viewpoint of what we have seen as microgrid deployments that generally occur around the world, is that we would like to look at situations where there is no dominance of one particular source. And therefore, we would expect that the deployment would be more economical, not relying on something really huge and other sources which are small added to it. But we would like to see how each source can then be economically added to it. Economics would rather describe or decide the different variety of sources. And then we would like to look at both decentralized and centralized approaches for microgrid operation. The decentralized approaches are good in a sense because you do not then need an overlay of communication infrastructure in order to operate the grid, thereby depending on the reliability of the communication infrastructure as well. So decentralized is good. But perhaps centralized approaches would lead to better energy management of the entire grid as well. So we would like to explore these ideas. The other aspect that we would like to see is that the sources that are used in the microgrid are not co-located. They, for optimal deployment, feasibility and ease of deployment, it is good if the sources are not co-located because resource availability may not be always feasible to bring to a particular source. And then we would also like to look at how to model these grids, which will then form the basis of deciding how much size of what source is required and how the grid itself should be operated in an economical manner. So these are all the different actions that we would like to have in our proposed center of excellence. And the phase one of operation, we would like to focus on all these technologies, which is waste to energy, and then steam, use of steam or use of in-process steam to extract some electrical output as well. Flow batteries, we would like to explore the use of microgas systems for electricity generation, high power electronics, which is of course essential when we talk of interfacing multiple sources to the grid. And for these kind of systems, therefore, the microgrid management systems is going to be very important. Photovoltaic is another source which is widely now used, and we would like to integrate that as well. So the phase one consists of these technologies from the viewpoint that many of these are already at various stages of development through research works happening at IITM, and we would like to pool these together to form a microgrid. While we move on to phase two of the activities, we would like to add more sources to that. Low speed wind is another one, and then hydro, which is again suitable for low flow and low head operation. Heat storage itself, we would like to use, and the SST, as this one is known, is something that is likely to revolutionize the way the grids are operating and grids are controlled. So we would like to explore this as well when we move on to phase two. So with that, then how do we visualize our microgrid to be? We would like our microgrid to first then consist of a set of sources, these kind of solar photovoltaic, which we already have deployed at IITM in considerable capacity, but we would like to see if some of them can be used or redeployed in the form of microgrid. So we would like to make use of these and then connect to the main grid itself. It's not only these, then we would like to look at certain other sources. As I mentioned earlier, we have a microgas turbine, which is being developed, and we would like to use that for electricity generation. And then the municipal solid waste plus a steam expander, which could then be used to connect to the grid via a generator. This is another thing that we would like to use, and then the flow battery based system. So these are not located at the same place. We plan for a separation of about 200 meters here, and this is about 400 meters. And then this entire system on the right is quite separated from the system on the left. And we plan to interconnect that by 11 kV line, which is again about half kilometer in length. And we would step up the voltage here and plan to step it down. And here we would like to be collaborating with MR as well, whom you would know if you are in the business of distribution. This will use an on-load adjustment of voltages, which is provided at the distribution level. This is the sort of microgrid arrangement that we would like to use. So sources are distributed, loads are distributed. There is some load here as well, and the network is widely spread out. So it does offer us considerable work in terms of research. This is quite ambitious to have and achieve, and we do hope to get there in some reasonable time. And in order to do this, we have a large group. Few of us here. This is myself, and then we have Dr. Arun, and then Dr. Lakshmi and Dr. Swarup. We are from the electrical side, and we would be looking at all the electrical interfaces, grid operation, and so on. And then we have Dr. Santosh and Dr. Murali, who are from the humanities side, who will look at the social interface of the entire grid to the local communities, the economics of it, and the regulatory aspects of this as well. And then we have Dr. Srinivas Jayanti, who will be coming in with the flow battery technology. We have Satyanarayan Seshadri, who is going to come in with the steam expander. We have Dr. Vinu, who will come in with the municipal solid waste expertise. And we have Satyanarayan Chakravarti, who is working in the aero department and is working in the area of gas turbines. So we have a large group, and when we move on to phase 2, for which research activities would start in phase 1 itself, we have Dr. Gopal, who works in aero area and would be working to develop low-speed wind as a source. And we have Dr. Dhiman, who will work in the area of low-speed hydro, both the ultra-low head hydro generation, as well as the low-flow hydrokinetic system. And then we have Dr. Srinivas Reddy, who works on heat transfer, and he would be coming in with the area of solar photovoltaic, which is where heat is removed by using phase change material. So we do plan to integrate a wide variety of technologies, and this will have several research issues at hand. Few of them are listed here, and there are many more. One is, of course, looking at the islanded microgrid operation. When the microgrid cuts off from the main grid, what sort of control structures are going to be used? And this is another interesting aspect, how supply itself, is it, do we get a high quality supply, nice sinusoidal waveforms, or is it going to be disturbed with a large amount of inverter fed sources that are connected to the grid and nonlinear loads? This itself could be an issue which we need to look at. There is a major research area in the area of islanding detection, and not just detection, resynchronization when the grid comes back. Economic operation of microgrids is another major aspect to this. How to size and optimize the grid itself is important. And we would also like to look at how AI can play a role in the operation of microgrids itself. So with this, how can those of you who are in the audience, how you can involve with all these initiatives? If you're students, one can then look at internships, and we are looking at good research scholars who can help us with all these activities. From the members of academia who are there listening to us, we would be interested in looking at intensive collaborations to develop the area of microgrids itself. And of course, microgrids are used all around the world, but I still feel we have a long way to go by way of optimally utilizing the resources, as I had outlined earlier as well. And we could have several workshops, and we do intend to have organized workshops as a part of this Center of Excellence. And it would be very useful to collaborate in organizing and learning from the workshops, from each other's experience in the area of microgrids. To the members of industry, yes, industry is ultimately the leading agency in the deployment and actual utilization of all the technology. So whether it is the technology we develop that you would like to use, or technologies that you would like to develop specifically, we could definitely explore that. And we could, though I have outlined certain areas of research, there may be areas of research and orientations which are more, more fit the deployment needs. So we could discuss that further and see if we can add more dimensions to the research that we are doing. The ultimate goal is, of course, to make use of these technologies and see whether this would benefit society. So site deployments are going to be a major aspect going forward into our phase 2 of activities, where we would look how these can be deployed in economical manners. And if industry, those members who are listening and you already have deployed sites where you have put microgrids, we would like to learn from those locations as to how deployments have happened and how people manage the grids, what is the economics involved, what are the load patterns looking like. This is very important for appropriate research orientation as well. So these are many ways in which we would like to involve and avenues where you could involve with us. So we do look forward to interesting days of research and deployments ahead. And with that, I'd like to thank you for your attention, and we are available for questions that you might have. Thank you,
Krishna.
and I'd like to stop the sharing. Yes.
Krishna, thank you very much for this broad and very intense dive into the complexity and the multitude of questions attached to the topic of microgrids. And I do see the first question. I will refrain from coming up with my own. I do see some questions, and two of them are somewhat interrelated. The first question addresses an important aspect: what are good locations or what are good conditions to establish a microgrid? And closely related to this question, research or activities on economics, because the location and the preconditions to establish a microgrid will be closely related to the question whether something like this will be economically viable and meaningful to do this, and not to have a large regular, quotation mark, grid supplying electrical energy to a place. Would you mind addressing those topics somehow interrelated?
Yes, Frank. So this is definitely a very important question, as I've been mentioning all along through the set of slides, that economics is going to play a very important role. So what are the good sites for deployment of microgrids? I would think that ideally a good site would be one where the necessity of having a microgrid combines with an advantageous economical situation. Ultimately, if a microgrid has to operate, be successful in operation, it must be economical to do so. If it's not economical to do so, it will go out of steam in a very short while. So the answer to this is that the need and the economics must come together. But I think that's not going to be, it's easier said than done. One would have to look at this in much more detail. Probably I would look at it this way, that out of the two, the need and the economics, I think need comes first, because economics has a way of adjusting itself and growing itself as energy becomes available. You see, in large number of situations, what we have, at least if you look at villages and so on, the issue is which comes first. Is it economics or energy? Is it economics or the development of the society? So these are interrelated. Unless you have energy that is available and they can use for developing economic activities, economics, there is no flow of financial resources. Unless flow of financial resources are there, you can't establish the entire grid and support its operation. So this is, while it is interlinked, I think some intervention is definitely required in order to break this loop, which is where the regulations and financial incentives or support will then have to figure in, and we will have to explore that. There's no exact hard answer to this, but these are interrelated, as Frank was mentioning, and we need to explore that further. But in my opinion, need comes first, and then economics that is added on.
There's a single word question, and I would like to ask you for maybe a single sentence answer. Is there something like a microgrid which is not smart?
I think not. I think not, because the very definition of a microgrid is that you are attempting to sort of put together different things that you want to operate at the same time. So some amount of intelligence has to go in. Probably there is a class of microgrids which I would not label as smart. And those are the varieties of microgrids that operate like an elephant in combination with a few ants hereby. The elephant is available. It can supply whatever energy you want to the microgrid, but then you put in a few ants around it so that the amount of energy that an ant needs, elephant need not supply. So those sort of heavily one-sided microgrids probably do not need much of intelligence to operate, is my view.
Thank you. There are a number of topics addressed in the Q&A. I would like to address one group, again, in a single set of questions. Some students do ask, how can they be interns, or how can they become interns? How can get students, because they were mentioned on the last slide also mentioned, what are possible contributions? What can they do? What do you expect from them? And yeah, please.
Yes. So there are several activities that an internship student can do. One of the things, as I mentioned, is field deployments, field studies that we want to do. Internship students can, once we have located suitable sites, we require the help of industry in identifying sites where microgrids are installed. So once such sites become known, then internship students, one of the ways is to involve themselves, is go to the sites and help us learn about microgrid deployments, microgrid usage, microgrid economics, community involvement, all these things. That is one aspect. There's yet another aspect where internship students can help in the research activities, is that we would need to model all these elements and look at simulations which will involve all these different sources being connected to the grid. And we require effort in order to model and effort in order to run different scenarios describing, which will explore the various ways in which microgrid, various operational conditions in which the microgrid would work. So exploration of these kind of these operational microgrids with the multiple kind of sources, load patterns, source variations, etc. That could be another thing where internship students could involve themselves. If the student is more skilled in a particular domain, for example, if the student is very good with embedded systems, then one can help us develop embedded code, which would be going into the operation of all the multiple inverters, converters, etc. Right. So, like this, there are different ways in which internship students could involve.
I just saw an interesting offer from a company called eHands Energy in the Himalayas, who are offering intern positions for interactions with the proposed Excellence Center.
That's really great. I appreciate that. We would like to start as early as we can learning about the field deployments and experience. We will certainly interact further with you on that.
Then there are two questions which are topic-wise related, but I think accidentally related. One question is regarding the efficiency or the potential of microgrids using waste energy from industry. I think part of the story has been addressed by you already, but perhaps you could mention some types of industry where this is most important. And the other question is a little bit more concerned. May there be waste from microgrids which might harm the environment. I cannot really imagine this, but perhaps I simply do overlook some aspects here. But please, if you could address those two questions again, somehow mixed or interconnected.
The first aspect was using waste from industry in order to operate.
Yeah, or waste energy from industry.
Waste energy, yes. Here we have Dr. Satyanarayan Seshadri here, who is working on excess energy that is there in steam. I would not call it waste energy, but it's really excess that is developed in the industry, excess steam energy that is developed in the industry beyond what the steam process itself requires. And he has come up with a way of extracting that energy and then sending it out into the grid. But there are, I'm also aware that there are other groups who have been trying to extract the steam energy, excess steam energy, and trying to get it converted to something of use. So definitely there is scope. When one looks at extracting energy from industrial systems, there are other overtones to this. And we are in this group, we are looking at those energy sources which are of reasonable capacity. We are not talking about extracting energy at very small levels, which is called energy harvesting. Energy harvesting generally refers to extracting few small watts. Even watt is a large output power. When energy harvesting is concerned, usually it is in the range of milliwatts, which makes some small electronics work, which could be used to energize few sensor deployments and so on. That's not our goal here. We are really intending to look at larger energy levels being drawn, and therefore potential aspect is steam. And I think Satyanarayan Seshadri has already interacted with several industries who have shown interest in this domain. So this is one. Then the next question is regarding whether microgrids themselves will generate waste. I think that waste generation is inseparable from human activity. If you don't want waste, even a person who sits quietly will have to generate some amount of waste. So anything that we would like to use is always, if you take a resource, you use something out of it, and something that is not used goes as waste. At least it is waste as far as usage of that resource is concerned for this particular reason. The remaining material, whether it is really waste in the sense it can't be used for anything else, or something else could be done out of that, is the essential issue. And in that sense, I really don't know whether you could call anything as waste. Even the so-called waste which is there in urban area, the municipal solid waste, we are now trying to see if that can be utilized for this purpose. So if it can be, then that waste is no longer waste. But out of the utilization, something else will remain, which is then the waste for this process. And therefore, research goes on. This is one of the ways in which we keep ourselves occupied, I think, by doing more research.
There's another group of questions which again are somewhat interrelated. Distinction between distributed generation, decentralized generation, and the microgrid. That's one part of the question. And the other question is, could you please compare, at least roughly, here the question relates to total cost of ownership. I would call it more the levelized cost of electricity between a centralized and a decentralized system. So this decentralization, how much more or less will it cost us per kilowatt hour, or whatever your measure would be?
Okay. So we'll take the first question. What is the difference between decentralized generation, distributed generation, and the microgrid itself? Now, distributed generation refers to the geographical location of the generating sources. Decentralized generation refers to how the generating sources are controlled. For example, if you look at the normal grid that is there, forget about solar, small solar that is connected and so on. The grid, the operation of the grid happens in a way that the amount of generation that is going to happen from each source, each major source on the grid, is a priori determined for certain slots ahead of time. So this person would go ahead and generate so much electricity, and how that is decided is again a large thing that goes into it. One has to forecast the load patterns and so on and so forth, and then look at how much that is going to be generated. So in a sense, the information flow and the way the grid has to function is centrally decided, that you so and so will have to generate so much at this instant of time. Whereas if it is completely decentralized, each person locally decides how much he or she should generate. That I would call it as decentralized generation. Distributed generation is all about the grid, where every grid, invariably all grids have that, in the sense generation is distributed. But what conventionally nowadays is called as distributed generation is, in a small area of grid, you have multiple distributed generation sources. The large Indian grid is also distributed in that sense, where you have multiple generating stations located all over the country. But somehow the name distributed generation hasn't really been applied to that. But distributed generation refers to sources where geographically they are in separated locations. The word microgrid itself then refers to a predefined area limited from an electrical sense, within which the interconnections can operate as an independent entity, or it can operate connected to an external grid as well. So this is then a microgrid. Why these are different is that many times, if you look at the microgrid deployments around the world, people do not necessarily have distributed generation when microgrid implementations are involved. They may use different sources, but they may all be co-located in the same place. Right? It has certain advantages with respect to the operability and control of all these sources, because they are all located close together. You don't need an extensive communication infrastructure in order to convey information from one source to another. So co-locating sources on a microgrid does have certain benefits to it. And that's why microgrids may not always have distributed sources. There may be non-distributed sources as well. I think the second question, now I don't recall having spoken to
it. Was a question if you compare the levelized cost of electricity in a microgrid. And I would like to include another question here, and that seems to be the last question from the group, because we are also closing to the end time. Microgrid in a village, is it possible? I would formulate the question slightly differently or more expanded. If you compare a microgrid as part of the electricity of the power supply in a major urban area with a microgrid in a remote village, both is possible. What is the difference? And then we are again back to the cost question in LCOE for a kilowatt hour or so.
Yes, the cost question about between a decentralized and a centralized microgrid. I do not have a clear answer to that at the moment. I would imagine that a decentralized microgrid would be a lower cost microgrid because of the fact that you need not have a extensive communication infrastructure. But one needs to really look into it more because we need to understand what kind of infrastructure is then required for the microgrid. Definitely, the electrical distribution infrastructure must be in place. Otherwise, you can't convey energy from one place to another. So that is, of course, essential. As far as the communication infrastructure goes, there are two varieties. One is the infrastructure that goes towards recording energy consumption, which basically does metering. And you need to acquire information from different meters in order to bill users for consumption of energy. So then the question is, how are you going to bill? And billing may require some kind of communication infrastructure if you want to do remote billing, or you want to send somebody around and do the billing. Those are aspects to be looked at. So there may be some infrastructure required for communication for metering purposes, and to know whether the grid is operating all right at different locations. You might want to deploy some sensors which will give you information regarding that. But when it comes to the centralized scheme, we are looking at a whole order of magnitude that's different, where a centralized controller will have to communicate with each energy source in deciding what is it that must happen for the energy generation. We want more, we want less, we want loads to be cut off, we want loads to be included. So that is a slightly higher level of infrastructure, which is definitely a communication layer. So the more integration you want into the system, the more unified command structure you want to build into the system, the layers of communication, I think, grow and would add to the overall ownership cost or operating cost of the system. This is what I think. The details of economics will definitely need to be worked out. Then there's a question of village microgrid versus urban microgrid. Yes, the village microgrid, I would expect needs to be more economical than an urban microgrid simply because of the affordability of users. Users who can afford more will demand more sophistication out of that. It will also mean that they will demand more source capacities. So you will have larger capacity-based microgrids and perhaps more sophistication from the viewpoint of control and system monitoring, usage, energy monitoring, and so on. Whereas in a village microgrid, we would like to be more sort of minimalistic and have only things that are barely essential, which the villagers can use and operate on their own without much of external help.
Krishna, thank you very much for this extensive answers to more than 20 questions out of an audience not far away from 200. So obviously you did well in attracting the people by doing or by bringing together lots of information about what is planned to be done in the Center of Excellence. And on a personal side, a remark from me, I will be happy to interact intensively with your group on this topic. Because many of them are close to my own activities as well, as you know. And so with this, I would like to say thanks to the audience, thanks for the organizers, and special thanks to you, Krishna, for preparing the presentation and being available for this extended discussions. And I do see a slightly nervous organizer because he wants to throw us out because the next session is about to begin. Thanks a lot. Have a great evening and have a great weekend.
Thank you, Dr. Frank. I mean, my sincere apologies for everyone for dropped out in the introduction part. I should be really thanking you very much for the wonderful session run by Professor Krishna Vasudevan and beautifully moderated by Dr. Frank. Indeed, to say it was really a great interactive session, and as usual, the audience have flooded the Q&A box with a lot of questions. So, dear audience, once again, thank you for the participation. Looking forward to meet you in the next webinar. Thank you once again.
Thank you very much. I'd like to thank Frank for agreeing to be the moderator and doing a great job. Look forward to further interactions. Thank you.
It was a pleasure, and hopefully soon again in Chennai.
Yes.
Person to person. Krishna, see you around.
See you.
Ms. Lisa, you can proceed for the closure.